Hello everyone, my name is Sustik, and for the last several months I have been working on a problem that on the surface looks very simple. When a person types a medical question into a AI chatbot, can we trust the answer? The project I'm presenting today is called Documed AI. It is a confidence-aware medical question answering system, but on retrieval-augmented generation, with a specific focus on reducing hallucinations, fabricated, incorrect, or unsafe medical answers. Built in Kathmandu for users in Nepal. But the architecture generalizes far beyond that. Let me show you why this matters. Here is the situation we are walking into. Patients all over the world, like you and me, are increasingly turning to chatbots before they turn to professional doctors. They ask about symptoms, doses, drug interactions, second opinions, and so on. And large language models like ChatGPT will reply fluently and confidently, even when the answer is completely wrong. Look at the example on the screen. A parents ask, my 6-year-old has a 39.4 degrees Celsius fever. How much ibuprofen can I give her? The chatbot replies with a confident, clinical sounding answer. Every single number is wrong. The dose is too high, the interval is too short, and the citation it gave does not exist. It was just fabricated. And here is the dangerous part. To the user, the answer looks confident, but the actual factual accuracy in the studies on this exact class of query is closer to zero. That gap between how a certain model sounds and how often it's right is the entire reason this project exists. So, why does this happen? Why does an AI confidently invent medical facts? The answer comes from how large language models actually work. An LLM does not retrieve facts. It predicts the next likely token. It is fundamentally a very sophisticated autocomplete. When the model has no grounding mechanisms, it fills in the gap with whatever sounds statistically plausible based on its training data. In casual conversation, that produces nice prose. In medical, it produces plausible harm. There are 4 root causes. You can see them right here. It is probabilistic next token prediction, not retrieval. There is no built-in factual verifications. The training data ages quickly, and medicine changes faster than any other field. And critically, the model's confidence is not calibrated to truth. It sounds equally confident whether it's right or wrong. This is the gap that the chart on the right illustrates between the smooth blue prediction surface and the actual ground truth point. That gap is hallucination. Now, you might ask, surely something already exists for this? And the answer is yes. 4 kinds of systems exist and none of them are safe enough for clinical questions. Generic chatbots like GPT. No grounding verification, it has no hidden confidence and rare refusal. The search engines, they pass the burden of verification to the user. The symptom sticker, it is rule-based, static, and can't reason about the new case. The traditional RAG system. Retrieve a document and generate, but with no verification step and no ability to refuse. The bottom row is what we built. Documed AI. Hybrid retrieval, sentence level NLI verification, calibrated confidence, fail closed refusal, and Nepal aware localization. I'll walk through each of those. I want to be very honest about how this project actually evolved because the system you see today is not what I started with. My original idea was simple. Build a basic RAG chatbot. Take the question, embed it into vector, look up the closest document in the vector, paste this document into prompts, and let the LLM answer. That was it. The prevailing assumption I had, and that a lot of people have, was hallucinations are caused by missing context. Add context, done. So, version 1 was OpenAI embeddings, a vector DB, a nearest no neighbors retrieval of top 4 chunks and prompting stuff. Single LLM call, no re-ranker, no verification, no refusal logic, no freshness aware. Then I started reading the medical AI literature seriously. And the deeper I read, the more I realized this was nowhere near enough for healthcare. This is the slide that fundamentally changed the project. The literature was very clear. Retrieval alone does not eliminate hallucinations. Models hallucinate even with the context. These are the 3 failure models I kept seeing. Wrong context retrieved, embedding similarity is not the same as medical relevance. The retrieval pulls the paper about adult dosing when the user asks about the child. The LLM then answers fluently, but on the wrong evidence. Mod 2, on what I noticed was the right context being ignored. This one is scarier. The retrieved chunk literally says contraindicated in pregnancy, and the model still answered based on its parametric memory, prior ignoring what's right in front of it. Failure 3. Still evidence. A 2014 guideline scores high on similarity, but it has been suppressed. The answer is technically grounded and is technically harmful. That is why when the project transformed from a simple chatbot, retrieve, generate and ship to medical safety pipeline, confidence aware, verification, freshness aware and fail closed. So, the system we are about to see is not invented from scratch. It's a 6 well-established research ideas is chosen into a fixed specific failure model I just described. Let me walk you through them quickly. At first, the parametric plus non-parametric pattern. The LLM doesn't recall medical facts. It reads retrieved chunks. The second, the hallucination taxonomy. This convinced me retrieval wasn't alone enough, and that's what we needed, a verification stage after generation. At third, a small, fast LLM model that can score entitlement between a generated sentence and its source. We use it instead of second LLM call, which would be slow and expensive. Further, the reciprocal rank fusion. Let us merge BM25 keyword search and dense vector search robustly without normalizing scores. And then we have domain-specific embeddings. Generic embeddings miss medical synonyms, but MedCPT clusters biomedical terms correctly. And last, we have selective prediction theory. Below is a calibrated confidence threshold. Abstaining it's mathematically better than answering wrong. 6 borrowed ideas, 1 integrated system. So, what is RAG? Quick primer on RAG itself, in case anyone needs it. The mantra is don't ask the model to remember, ask it to read. The flow is when the user asks the query, it embeds it into a vector and search the medical corpus stored in pgvector, our database. Pull back the relevant chunk, put those chunks into an LLM prompt and generate a grounded answer with citations. Why it helps? The model is forced to answer from text it can read, not from blurry parametric memory. What it does not fix. If the retrieval is wrong, the generation is still wrong. RAG moves the failure point, it does not remove it. That is why the rest of our pipeline exists. Plain RAG still fails in 4 specific predictable ways, and for one each we have a specific fix. Wrong documents come back, embedding similarity is not equals to medical relevance, that is, we can fix hybrid retrieval BM25 plus dense with cross-encoder re-ranker on top. The model says things that the source doesn't. Fix the sentence level NLI verification. Every generated sentence is checked for entitlement against its cited chunks. The evidence is out of date. What we did? We fixed the freshness weightage ranking. Newer guidelines win ties. And the last, it always answers even when it shouldn't. What we did? We fix it by fail closed refusal. Below is a confidence threshold the system abstains. These are the four retrievals. These are the four fixes: hybrid retrieval, NLI verification, freshness weighting, and fail closed refusal are the four pillars of the system. So, what is Documed AI? A confidence aware medical RAG system, not a chatbot. A medical evidence navigator with 5 stages, safety pipeline, sentence level verification, and right to refuse. Let me show you how the whole thing works. This is the full system, 16 components organized into 5 stages. I'll walk through left to right. At first, when the user queries, before everything else, every query hits a red flag engine. If the user describes something life-threatening, chest pain, stroke signs, heavy bleeding, we don't try to answer. We escalate immediately. Call 102, go to ER, stop. After that, intake. If it's not an emergency, we classify intent. Is this a symptom question, a drug question, an administrative question? Then the intake engine asks for context that changes the answer. It asks current age, medication, pregnancy, allergies, and we rewrite the query according to the canonical form of retrieval. Stage 2, retrieval. This is where the hybrid search happens. 3 lanes in parallel. Dense retrieval using MedCPT embeddings, BM25 lexical search using pgvector, and reciprocal rank fusion to merge them. And then we pass the merged candidates through a cohort cross-encoder re-ranker. And then the coverage gate. If we don't have enough confident evidence, we refuse here rather than generate. And at stage 3, we have generation, the grounded LLM call. We use the grok for fast interference with 3.37 billion parameters. The prompt strictly instructs the model to answer only from the retrieved passage and to attach a citation to every claim. Then we have verification. This is our strongest contribution. A debugged V3 NLI model scores entailment per sentence. Each sentence gets a confidence score. We pass it, soften it, or reject it. Citations are attached and only then the answer reaches the user. Notice the dotted red line at the bottom. That's the refuse path. Any stage can trigger it. That is a heart of a failed closed design. Let me reinforce what failed close actually means, because it is a single most important design decision in this project. Every one of these 5 gates can refuse. If any gate isn't confirmed, the pipeline stops. The user gets a referral, a follow-up questions, or an honest, I don't know, instead of wrong answers. The gate 1 detects emergency and refuses to ER. The gate 2 asks for follow-up questions if it doesn't have enough context. The gate 3 refuses if there isn't enough strong evidence in the corpus. The gate 4 refuses if the LLM can't ground its claim. The gate 5 redacts sentence the verifiers can't entail. Compare the 2 boxes at the bottom. A typical chatbot is fall open. When it isn't sure, it answers anyway, confidently and wrongly. That is actively dangerous in medicine. Documed AI is failed closed and when it isn't sure, it refuses, asks for more information, or sends the user to a clinical. Says nothing is safer than guessing. That principle is frankly the whole project is one sentence. This is the slide I want to dwell on because this is a technical contribution I am proudest of. After the LLM writes its draft answer, we don't just hand it to the user. we split them into individual sentences, and each sentence is sent to a second AI, a small debugged V3 NLI model, which compares the sentence to its cited source and decides one of three things: keep, soften, or remove. The example on the right is the real trace from our system. 4 sentences about pediatric fever. Paracetamol is first line. Entails at 0.94, pass. The ibuprofen may be added after 30 minutes, neutral, and is soft. Aspirin can be used in children under 12, contradicts at 0.18, rejects. Aspirin is in children is associated with rare syndromes. A verifier caught a dangerous claim. Seek care if fever exceeds 39 for 72 hours. Entails a 0.91, passes. The response level confidence is 0.84. That number shown to the user, and that is what calibrated humility actually looks like. Brief but important, medicine has a half-life. A 2014 guideline and a 2024 guideline can disagree completely. Cosine similarity has no opinion about time, but we should. So we apply a freshness weight and roughly a 5-year half-life. A 2014 dosing guidelines weighs at 0.07, almost nothing. A 2019 review at 0.37, useful background. And a 2024 ACOG update at 0.81, surfaces first. Rule of thumb: anything older than 10 years contributes nearly zero unless it's the only source available. Anything from the last 2 years gets near full weight. So, this is where the project becomes specifically mine and specifically Nepali. A US trained medical AI giving triage advice in rural Nepal is not just unhelpful, it's completely wrong. Here's why. Self-medication is the norm here. A pure refusal isn't useful. The system has to point to a real next step the user can take today. Specialists cluster in Kathmandu, Pokhara, and so on. Telling a rural user to see a cardiologist is a dead end. Drug names and formulations differ. Nepalese pharmacies don't stock what US guidelines assume. Emergency is 1-02, not 911. Hard-coding US emergency numbers in a refusal can literally cost minutes. So, Documed AI is aware of Nepal's 4-tier care system: primary health center, district hospitals, zonal hospitals, and teaching hospitals, and so on, and routes referrals appropriately. Emergency route to 102, 100, or 1115 depending on the type. So what have I used here? The stack. It's very fast and observable. Front end is in React, TypeScript, Tailwind, and so on, with backend like Fast API, LangChain, and so on. The AI we used, Llama 3.3 with 70 billion on Grok for text generation, MedCPT for embeddings, Coher re-rank for cross-encoder, and a debugged V3 for NLI verification. Data. For data, we used a Postgres Supabase with pgvector for the dense index and BM25 for lexical index. Nothing exotic, every choice is justified by predictability and observability. Similarly, our build journey started from a naive RAG, which led to the MedCPT embeddings and adding BM25, and similarly adding Coher re-ranker. That's the retrieval code. And then we did the red flag triage, NLI verification, confidence calibrations. That's the safety layer. And then we did freshness decay, Nepal localization, hardening evaluation, ship. That's production. At the point of this slide is the architecture wasn't designed upfront. It grew in response to the specific failures I observed in the real evaluation runs. Now, to results. Evaluated on 320 held out questions from MedQA and Mirage, with 3 rater agreement on a 80 question subset. The hallucination rate 62% on baseline LLM, 18% on Documed AI, a 71% relative reduction. Retrieval recall at 5, 0.54 for baseline and 0.87 for hours. Groundness, fact scores, 0.48 for baseline and 0.86 for hours, a 38-point improvement. The refusal accuracy, measuring whether unsafe questions get correctly refused, that is 0.11 for baseline and 0.79 for hours. This is the metric I care about the most. The baseline LLMs almost never refuse. Documed AI refuses correctly 4 out of 5 times. The faithfulness via NLI entailment, 0.51 for baseline and 0.88 for hours. Across every metric we cared about, Documed AI is meaningfully safer than the baseline LLM. And the metric that improved most, refusal accuracy, is one of the most that matters clinically. Let me trace one real query end to end so you can see the pipeline in action. So what I asked was, is amoxicillin safe in 3rd trimester for urinary tract infection? What we did, the retrieval find 8 candidate passages including ACOG and Corinth. It shortlisted, Ranker keeps the top 4, ACOG 2023, Cochrane 2022, WHO 2024, and BNF 2024. What it drafts, the LLM writes a grounded answer using only these 4 sources. Every key claim tagged with a citation. It checks. The NLI verifier checks each sentence. All 3 sentences are backed by sources. In step 5, it shows the user sees a clean cited entry. Yes, amoxicillin is considered safe in the 3rd trimester for UTI. Typical course, 500 mg 3 times a day for 5 to 7 days. And please confirm with your doctor. The total round trip, roughly 3 seconds. 3 times slower than a plain LLM call and worth every millisecond. So, now the honest part. Documed AI helps you think. It does not replace a doctor. There are 6 limitations. At first, we have the corpus mostly in English, and it is not medically certified. No regulatory approvals. Similarly, it struggles on the rare case. The corpus is thin on rare disease. For now, we have just done the general medicine corpus, and the system refuses more often than it's not there. It is slower than plain LLM. This also adds the safety net for it, and only be good as the corpus. Bad input, the bad the corpus, the bad the output. And the verifier isn't perfect. Myself verifying, it leans towards refusal by designing. Every one of these real trade-offs, not a thing I am hiding. So, what do we do next? For the next 6 months, we can figure out the multilingual Nepali to English retrieval using XLM, a live ingestion to a new PubMed and WHO and WHO publications, and a clinician feedback loop. In the next months, we can do adaptive retrieval, self-reflective RAG which verifies and rewrites the loop, and multimodal grounding for radiology images. Furthermore, we can also use voice for low literacy users, hospital integrations, and federated medical knowledge across Nepalese hospitals. The thesis ends here, the product doesn't. I want to zoom out for a minute because I think this project is bigger than just one chatbot. Trust isn't a UX choice, it's an architectural choice. Every domain that touches consequence, medicine, law, finance, education, is going to need AI systems that are willing to say, I don't know. The question isn't whether AI will mediate these interactions. It's whether the AI doing it will have a refusal path built into its architecture. 4 principles that came out of this work. Calibrated humanity. Confidence should match evidence, not fluency. Auditable answers. No grounding, no answers. Human in the loop by default. The clinician decides. Failed closed always. Silent is a feature. So, I started this project trying to build a chatbot. I ended up exploring one of the deepest open problems in modern AI. How do you make intelligent system trustworthy? Documed AI is one answer. Partial, opinionated, and built in the open. I hope it's a useful one. Thank you.